Hello and welcome. In this episode, we're going to answer the question, how does the Earth move? Before we begin, please grab your packets and open up to page number 2. We'll be filling out the top half of this page through this video. So, how exactly does the Earth move? Well, as we know from our discussion of the solar system, the Earth and all the planets move in two ways. They all revolve around the sun, and at the same time, they rotate around their axis, or spin. Let's take a closer look at each of these motions, beginning with revolution. Here you see the Earth and its orbit around the sun. The Earth will complete one orbit or one complete revolution in about a year. Let's jot down some notes about revolution. Take a look at the top box on your handout. First thing is simple. We need to know that the Earth revolves around the sun. And one revolution of the Earth around the sun takes 365.26 days. Or a year. Now you don't need to memorize this number because it can be found in your reference tables. If you were to go into space above the North Pole of the Earth and the North Pole of the Sun and look down on them, you would see that the Earth revolves in a counterclockwise direction at a rate of about 1 degree per day. Now understand where this 1 degree number comes from. One revolution is essentially a complete circle around the Sun, 360 degrees. And it takes the Earth 365 days to do this. So if you divide 360 degrees by 365 days, you get a revolution speed of about 1 degree per day. Now, the revolution of the Earth has some major impacts on us, and these include all yearly changes. So if you think to yourself of any things that happen over the course of a year, any cycles that change yearly, most likely they can be traced back to the Earth's revolution. The most obvious example are the seasons. We know we go through a full cycle of seasons every year, so they are caused, at least in part, by the Earth's revolution. Another interesting change is the ability to see different constellations of stars at different times. If you go outside from New York in the winter, you will see the constellation Orion, but in the summer, it's not visible as the Earth has moved. Let's draw a quick sketch with the sun in the center and the Earth on the side and the Earth's orbit. Be sure to include the arrow showing that counterclockwise motion. Let's talk about rotation for a moment. Rotation is the Earth's spin on its axis. We complete one spin every day. Let's jot down some notes about rotation. So the Earth rotates or spins around its axis of rotation. Now the axis of rotation is this imaginary line from the North Pole to the South Pole, around which we spin. One complete rotation takes 23 hours, 56 minutes, and 4 seconds. But you could leave off the 4 seconds. Essentially, one rotation is 1 day. Now, if you were to look at the Earth from the side, at the equator, it rotates from west to east, and it spins at a rate of 15 degrees of longitude per hour. That is 360 degrees divided by 24 hours, giving you 15 degrees per hour. Now, while the revolution caused yearly changes, rotation causes daily changes. These are things like the sun rising and setting each day, the stars appearing to move across the sky, and a variety of other things, including day and night, the apparent motion of the sun, moon, and stars, something called the Coriolis effect, and Foucault's pendulum, both of which we'll discuss more in class. Let's sketch the Earth's rotation. Here's the Earth. You see the axis, this imaginary line through the North and South Pole, and you draw an arrow to show the west to east rotation. So let's take a moment and take a look at what all of this actually looks like. Okay, so here we can see the inner part of the solar system. Let me just turn the time on and get us moving a little bit here. And if you focus right here, you'll see the Earth, and you can see it rotating around its axis once a day. And at the same time that it's rotating, you can see by this blue path here, that is its orbit as it revolves around the sun. Now, in order to see a revolution take place, I will have to speed up time as it happens pretty slowly. It takes about a year. So I'm going to increase, let's do it daily. And here you can see the Earth spinning once a day, very quickly here, as it is revolving around the sun. Also notice some things we learned earlier on, which are that the planets closer to the sun, like Mercury and Venus, take less time to orbit, while as you get further out, they take more time. So there's the Earth rotating as it is revolving. I can turn this to the side a little bit so you can get a better idea of what it looks like, and I can zoom in so we can see what this looks like. Now as the Earth comes around the backside of the Sun here, I will slow it down so we can get a closer look at what the rotation actually looks like. So I'm going to stop it here, and we will go a little bit slower. And so here you can see the Earth rotating. And it is, though it doesn't look like it, it is still revolving around the Sun, but remember it's only moving about 1 degree of the complete orbit per day, so it's not a very noticeable motion. We are spinning 15 degrees per hour, we are revolving 1 degree per day. We are spinning from west to east, and from above we are revolving in a counterclockwise direction.